is Samko. It's a fine day, I'd like to say, but it is kind of rainy and miserable. I flew in from Melbourne today just for this, and it's like I've never left. Yeah, so feel very welcome and very at home. Today, I'm going to talk to you about how to build your recommendation engine using Neo4j, and how easy it is to do so, even without a lot of like different fancy skills or like knowledge. So you can, I don't think this actually works. Might have to use that. That's fine. I'll be glued to the. So as I've said, my name is Samko. I started my first job as this little company called LG. I don't know if you know this. And then I started out there and then worked off to different companies, different IT consulting backgrounds. Worked with a lot of different industry, as you would do in the IT consulting. And then recently, I found myself in Neo4j because last project that I was running happened to be building business analytics tool using a lot of different technology, database technology, and then Neo4j happened to be one of them. And I thought it was a really nice, nifty little tool, so apply for the job. All right, so this is the agenda that I'm going to walk through today. I'm going to just briefly introduce what GraphDB is, and I'll introduce the real-life case studies, and especially in retail, and then how they built their own recommendation engine using Graph database. And I'll move on to how we can actually build one hypothetically. So the section 3 is kind of like, we're like imagining we're building one together, and then what steps, what kind of consideration you would go through normally to build one. And I'll do a quick GDS code walkthrough. So GDS here is a graph data science. Now we call it graph analytics. So, however you want to call it, it's fine. There's an inherent benefit of having your data as a graph. So you can actually run some graph theorems. And then I'll tell you if there are some cool resources you can use to learn and upskill. All right, what is graph? When you search graph on Google, this is what you're going to see. Whole bunch of graphs that you can actually, typically you would call graph. But what the reality is, this is actually charts, and not exactly what we're referring to here. When we talk graph, we mean this, nodes and edges connecting to each other, and we're talking about the graph theorem. So graph theorem is Graph theorem is basically a study of graphs, as you can understand, like what the name suggests, and mathematical structure of graph. So what it can apply to is a lot of different areas in real life. You can use it for, you can often find this graph in social media, how I'm connected to you and how you're connected to your people, like your friends on LinkedIn, social media. And you can also do the same thing with the fraud detection. One of my favorite TV show is like CSI. And you see all the detectives always kind of like putting the push pin on the board and then trying to see who's connected to what and trying to figure out the pattern. So that's kind of like quick representation of like what TV presents as a graph. Now, how do you apply that graph technology to your day-to-day business in your company? How many of you have heard of Neo4j before today? If I show of hands. Oh, okay, wow. Most of the people have heard of Neo4j, which is a pleasant surprise for me. So I don't have to spend too much time on this. So Neo4j is like one of the pioneer and also the leading database technology company in the industry, and that we have helped numerous different clients, as you can see on the screen, plus a lot of local companies that you might have heard of, a lot of banks and a lot of like logistics company, and to name a few. The reason why they're using graph is because they are building all this little thing called knowledge graph. If you ask 10 different engineers about the knowledge graph, and they would have probably 10 different answers. So very simply put, it is it's a database technology to organize information in the form of edges and relationship, much like how it really represents in real life. Instead of trying to trying to explain what Mona Lisa is, and this is roughly what I would draw on the whiteboard, right? You're not gonna start a table, art piece, artist, and then like the mapping table of which artist done which work, and then where do they live. All of that, it's just like tabular format. If you were to do that in like typical database, it's gonna be a lot of processing in the background. That's why Google is also using knowledge graph for their search to improve their search results. So if you search for example, like Antonio Gaudi, you start seeing a lot of relevant panel, like on the right side, on the bottom side, who are the relevant people. which work has done by Antonio Gaudi is most well received, like in the popular. More relevant information is what I say. And again, why knowledge graph? Because it puts the data to context. It's not just about the like rows and columns of data. You're actually like connecting the data for your application, for your users. So like at the query time, you don't have to run a lot of different like joining, making sense of it. All the data is already connected to each other. And then that is also a really good way to kind of leverage both your structured and unstructured data set, as you can see on the graph here. So on the top side, you have your typical tabular format. You have customer table, product table, and then each product might have a document. And so this is kind of like a quick representation of what the graph rag would look like. And you would start processing the unstructured into different sections of the graph, and then you make a chunk and then create a vector embeddings, whatnot. But beyond that, what you're doing is what you can do is you can also extract entities and relationship from those documentation and connect that to your structured data set. So you would actually have a lot more valuable, more like connected insights of your data. So when your LLM is asking questions, so you can actually traverse from feature to product to customers to leverage both side of your data instead of having a fraction of that understanding and then stitch the data for your LLM. But unfortunately, I'm not going to talk about GraphRag today. I hope you're already well aware of it. Today, I will talk more about the basics of Graph, how you can leverage that to build the recommendation engine. The Graph database, as I've said, is very nifty tool. Probably one of the biggest benefit of using Graph database is compared to tabular format, you don't really have to join the tables to ask complex questions about certain things. So funny when you say like relational database, it's really kind of suck at giving you the relational questions. Like, the moment you start asking complex questions, you have to start joining 3, 4 tables. There's a self-join. There's like, a lot of like, once it goes more than millions, it becomes exponentially expensive. Whereas in Graph database, all the relationship is established at the right time. So when you're actually asking the question, you're just traversing from point to point without joining, like without any index lookup. So we call it index-free adjacency. You don't have to understand it immediately, but point is, point traversal is not something that you have to worry about even when you're scaling out in your business. So even if you ask questions that are 20 hops, 30 hops away, the processing processing expense is going to be just linearly growing instead of exponential growth. What you would see with the relational database. So even though everybody is mostly aware of it, I'm just going to quickly run through this, but I'm not going to spend too much time. So the components of the knowledge graph is we have nodes as essential entities. So that will represent the object. So if you have your like person, customers, or like a vehicle, whatever have you, all of those entities and objects will become the node. And then we have relationship between the nodes. So the person knows another person, and it could be living with another person, and then the person drives, and then basically relationship, like how it connects to each other. Not really difficult, right? And then as you can see, the relationships always have a direction. So it has to be directional. For example, nodes relationship, they're established both ways because, just because I know you, it doesn't mean that you know me. So like, but there could be also relationship that could be inferred based on one direction. For example, if I'm married to someone, then by definition, they're married to me, I hope, like they know that. So in that way, you don't have to establish 2 different relationships. One relationship is enough because traversing doesn't really hinder you from like, orientation wise. So like you can traverse backward, front, or like however you want. And lastly, graph database, Neo4j is property graph. So meaning that we can store a lot of like contextual property information, not just on the nodes itself, also the relationship. So you can see the person, let's say Andre, has been driving Volvo since 2011, January 10th. And there's a lot more contextual information you can store within the relationship, which would be very powerful. Because if you map relation to graph, rows become the nodes, and the join, you have join table, well, that becomes relationships. And then you have table names, we'll just call that label of the node. So if you, as you saw in the previous chart, so the person would be the label, and then vehicle would be the label. But you have a lot of rows that become the node. And the columns, what you store within the columns you would store in properties. So this is very easy one-to-one mapping. Having said that, it's not as straightforward as like a mapping, like certain like creating the graph model out of your tabular format. It is still, there's a lot of tools that you can actually start off like quite easily. But once you start asking questions to your graph, you're going to quickly realize, oh, so there are actually a lot more like optimization, let's say, like, or like different things you can do with the graph, the way you're storing the data. And then what other use cases can I now that I know what graph is, what kind of use cases can I actually use this for? So there are a lot of different use cases. Graph is quite natively helpful. Real-time recommendation engine, which is what we're going to cover today. But aside from that, fraud detection, as I've mentioned, I'm a big crime investigation show fan, and then there are a lot of banking and financial institute, and even like police department. They're actually using this to find the pattern of the certain fraud or like criminal activity. And IT network, as you can imagine, is like very natively and naturally graph. And master data management, risk compliance, all the other use cases. These are the companies that we're actually benefiting from using the graph for that. But let's focus on our recommendation engine use case. Recommendation is everywhere. You would be probably well aware if you have social media, which I also do. And whatever I talk today is going to pop up on my Instagram later. So I need to be really careful what I'm saying. So recommendation is not just for your social media or like retail websites. So you can do that on the job searching. So one of our customer actually built their career model on of knowledge graph. And so like, depending on their skill set, on project they're involved with, their manager can actually use this knowledge graph to like find the next best skill for them to upskill, or like how they actually connect with different people. In case of absency of someone else, we can actually replace that temporarily with people with similar skill set. So that's kind of like a different type of recommendation. And you have travel, route recommendation, retail, which we're going to again talk about, and then healthcare. So AstraZeneca actually used the Neo4j for patient journey optimization recommendation. So depending on the progress of their disease, they would see and they would get connected to a lot of different health experts, right? And then, the end goal of any disease is perfect curement. And we'll see in that journey and what is the shortest path like for one patient to get to the curement. So that is the path they're like mapping out in their data set. And whenever somebody new is getting onboarded, like with a similar symptom as the one that we already have a lot of data of, then we know exactly what process for them to go through, like what kind of recommendation we can make for them. Like, oh, probably we can recommend this specific drugs as these specific experts. So that's kind of like a customer journey, patient journey recommendation. So there's a lot of different types of recommendation when we are saying recommendation. But today we're going to keep it very simple. We're going to talk about fun thing, shopping recommendation. So what's in shopping? What's in retail recommendation we typically see every day? We have product recommendation you would see on when you go on a website. Oh, you might also like this, and oh, this a lot of people actually like purchase this. These kind of little things that you see, that would be kind of like recommended product recommendation. And promotion is something that we always ignore, from emails to nowadays like getting like force fed to us from YouTube and social media. But they're surprisingly relevant. And I recently got scammed. They said they hacked into my account and sent some random message to all of my friends. And I was very confused because it was genuinely something that I would have sent to my friends, so I wasn't too bothered. And then there's a logistic delivery recommendation. If there's any road disruption, we need to quickly find out the optimal route depending on the road condition and what we're carrying. There's a lot of different, again, even within retail, there's a different types of recommendation we can. So the case study that I want to mention is Walmart. I'm sure everybody is aware of it. Walmart, the massive online retailer in US. So what they have done is they wanted to obviously, like upsell and cross sell. They want to make sure they're actually personalizing the recommendation for their customers instead of just like, oh, this is kind of popular, so you want to buy this. It's like, yeah, I don't want to buy. I just want to find something that is relevant to me, right? So that's what everybody's doing. So they created. But like the problem is making recommendation off of the relational database. They have hundreds of millions and maybe billions of like a product like operation record. And to make sense of those insights and then make some relevant recommendation using relational database, was very challenging. For processing time-wise, also in real-time recommendation, there was a lot of limits. So they decided to start creating product knowledge graph, as you can see from here. So let's say they have ottoman, sofa, and each of the product would have the detailed information about the concrete entity, like attributes like couch, what shape of it is, what material is it made of, and what room is it designed for. And then you also have abstract entity that kind of represents our more modern style or antique. That everybody has their differences. So based on your behavior purchasing pattern, you can make a lot more personalized recommendation. And so that are like, people are more prone to like buy more stuff on your website. And this is what they have built. Like this is a sample I want to kind of talk to you about. And then I'll go into a much deeper level after this. But let's say this is the purchasing graph that they have in Walmart. And you see different nodes represent different objects. The pink nodes are the session, the online session. For each session, they would purchase or just view products. And the orange dots are the customers. And then the rest of it is just a product. Just think of it that way. And let's say we want to target Mingo and the person. What product can I recommend to the Mingo? This little person have purchased, let's say, light fixture. Okay, that's the only thing that he has done. Like based on that, what can you recommend to him? Any idea? Yeah, light bulb. So exactly. Good. So there's a light bulb that has been purchased along with the light fixture by Jane. But because they are purchased with, I'm just like very simplifying. Like, obviously we're not going to go off of like one purchase data, right? But because fixture also is, light bulb, fixture, they're complementary to each other. And light bulb, look at the little brand that it belongs to, and then there's another light bulb. Very similar to that one. You can directly recommend the light bulb to Mingo, but there's like similar light bulb. Maybe you can expand even further using your graph and traversing. And we're recommending that one to Mingo. So this is based on what we're calling collaborative filtering. Beyond just what your customer is immediately doing, we're kind of like creating a big data contributed by a lot of different users. So that's the pattern. That's easy traversal that you can do to recommend different products that are outside of Mingo's usual kind of recommendation set. Another way you can recommend is based on the customer profile. So let's say Mingo and Aditi has attended a design one-on-one conference, apparently held by Walmart, whatever information you have access to. Then we decided these two customers are relevant or like in the same community based on their interest, right? And let's see what Aditi has purchased. And Aditi has purchased antique lamp and throw pillow and some other product. And then we, like out of that, because he's kind of interested in light bulb, maybe we can also recommend the antique lamp. So that is based on the customer profile recommendation. And we're going to look into both of them a little bit, and then perhaps like even the more lower like code level analysis later. But this is what you can do with the knowledge graph. Like everything is like pre-connected without having to like, oh, let's see, like join all the like purchasing data and customer data and product data separately, and then trying to see if there's, to make any sense, like let's see if there's any insight. A lot of analysts will spend hours, days, months just looking at the Excel sheet and tabular formats like, does it make any sense? It really doesn't. But when I actually put it in a graph, it's easier. Now, let's say we are building recommendation engine. We are all in the same company. I hired all of you, and we are going to build amazing online retailer. And we have two data available to us. Let's keep it simple. We have customer data and we have product data. And customer data is not just the demographics. We also have their session purchase information. And product data, we have product name, brand information, category, and maybe even some like seasonal event information. Now, what should we consider when we're making a recommendation? These are 4 things that everybody should consider, and then like not everybody actually consider every single aspect of it. So my customers, one of the customers that I recently worked with, they focused on the customer behavior a lot more than customer demographics, which is fine. But power comes in when you start like adding a lot more. You don't have to do everything all at once, but once you start like adding in more dimensions, it's going to make the quality of your data a lot better. And These are the 6 type of recommendation that I think is like really relevant to all the retailer or any kind of recommendation. Let's say, how many of you have a home office here? I think most of you have. Yep. Okay. So let's say we're buying a desk, and then you will go onto the website and see what desk is trending, popular. Okay, great. I'm gonna start looking, clicking, and then based on what I'm clicking on the trending products, it's going to slowly recommending similar product, which is the type 2 product. Yeah, trending is very easy. It's based on the person's data, like the history of data, but it's not personalized at all. It's not usual recommendation. Similar products is a level down. Okay, I'm start seeing more things that I like, but it's not quite there. But I have managed to find the desk and I purchased it. But now it's keep recommending me all the desk, and I want to see more than that. So that's where you go into the complementary product. So now that I have a desk, I'm not going to buy another desk, but I am interested in buying a desk and maybe some other office supplies. So complementary product would actually make recommendation cross a lot of different products, as you have seen before. That what items are often purchased together with. So that's what we're making recommendation. Again, great recommendation, but it's nothing personalized about me, what I'm doing. That's why we're going a level down, type 4 affinity-based recommendation based on what attribute the products that I've purchased is going to start slowly making recommendation. I have a lot of black furniture. Then maybe it's probably better for them to start like recommending me something in black color and similar material. Problem with that is, if I start buying 1 or 2, and you can actually get stuck in this echo chamber of like them recommending me only the black colored products. I might want to switch it up a little. And if I don't have enough purchasing data, that's the limit. That's actually a genuine practical problem in a lot of companies. They don't always have abundant of data available to them. So that's why you need to bring it to the community, bring it to the collaborative filtering level, which is number 5 and 6. 5 is based on your profile, how similar a certain customer is to other people, or like to the group of community of people. So you can actually expand the data set they are doing instead of just focusing on one person, what they have purchased. So this is the level of, and then like I said, the last 3 levels are slightly off, but last 3 are actual personalization. Beyond that, it's just a typical recommendation. Even if you do like level 4, this is pretty fine. Like you're going to see a lot more valuable results out of it. Now, how can graph help beyond that? As I've mentioned, the graph data science is another offering from Neo4j. We have 65 plus different algorithms you can run on top of your database. You don't even have to understand exactly how that run. We have an extensive documentation of explaining how that works in theoretical, like graph theorem, and then like mathematical equation, everything. Honestly, I don't really understand half of it. But we have a lot of different algorithm, pathfinding, centrality, community detection, link prediction, similarity, and lastly but not least, graph embeddings. So these are all like quite valuable, but they all answer basically 3 main questions: what's important in your data, and what's unusual in your data, and what comes next. So in recommendation, there are a few things that I can recommend, like looking into, because like I said, we have like 65 plus algorithm. I don't want you to look into every single thing. So connected component algorithm would actually identify this island of isolated connections. So we can actually identify unique customers, unique users that are not really connected to any other customers for some reason. This also can be used for fraud detection, like out of ordinary, what's unusual. Page rank. So this is kind of giving you what node is very important, like what is most connected node in your data set, and then kind of gives you impact in your sales, impact in your data product, impact in your customer network. Louvain, Leiden. So they are also another type of community detection algorithm. Aside from the connected components, Leiden, Louvain give you the modularity degree. So it kind of calculates everything for you. So basically how densely a certain community is. So based on that, you can create a customer segmentation. And Jacquard FastRP, so they are similarity and graph embeddings. Long story short, they basically tell you how similar you are to other people, or how similar one product is to another product, not purely based on text embedding, text recommendation, based on how many connections you share with the other node. Yeah, so that's like a lot, like almost like a small subgraph of your profile that you can actually compare. So there's a lot more context you can actually bring in. quickly, time check. I don't have enough time to do the explain this particular algorithm, so I'll just like jump right into the code walkthrough, which is the last. Second. So this is the Python notebook that I've just written for like creating the graph embeddings for using the core purchasing pattern. So what we are doing is based on what customer has purchased what, I'm going to make sure I'm going to try to find a complementary product of that product, right? And then instead of just like all similar products based on that. So this is what I'm doing. We're setting up. Don't have to worry about that. Just like setting up the connection to the database. And then if you look at that little code, what I'm doing is, in order to run the graph data science algorithm, you need to project part of your graph onto in-memory. So we call it graph projection. So I'm making graph projection. And if you look at that, this is the cipher query, by the way, that used for Neo4j. It's quite easy to understand. It's kind of like ASCII code. We're looking at customer purchased a certain product, but we're going in both ways. So we're trying to find like two different products that are purchased on by the same person on the same session, and we're going to connect them, calling co-purchase, into in-memory graph. And then after that, we're going to run GDS algorithm, and this is easy. This is how easy it is to run the graph algorithms. You just like GDS fast RP or whatever algorithm you want to run, and we have a lot of documentation how to set certain configuration. Not going to go into the detail. You run that. Basically, what fast RP does is it creates a graph embedding. So it basically creates how similar one product is to the other based on the purchasing pattern. And we're going to run the k nearest neighbor to weed out all the noise. And I'm interested in just like the highly purchased together, not every single thing. Just because one product has been purchased once with the other, I'm not going to make much sense out of it. So that's what I'm doing, cleaning up. And after that, you can ask questions like, okay, this customer is looking at Shangri-La Storage Ottoman Bench. What can I recommend to them? So this is the list of product you can see. I don't know if it actually is big enough. All right. So based on that Shangri-La Ottoman, which is, like the bedroom ottoman, right? So you would recommend, okay, so a lot of people who purchase this ottoman, because of the style, or maybe they are also bedroom items, they're recommending like wall decor and lamps and pillowcase and these comforters. So these are all the like relevant cross-sell you can make, your cross-recommendation you can make, not because they're trending, because these items specifically has been purchased the most often with these items. All right, and that was a very quick walkthrough because I don't have enough time. Sorry, I should have probably showed you this. It's very easy graph model, as I've said, customer, product, attribute, and class. Attribute is just the black color, what letter. And this is what I've shown you on the right side, complementary product. However, what you can also do, because you have a graph, you can also do the peer-based recommendation based on what they're purchasing. You can connect two different similar customers together. And then you can look at if you're recommending to customer A, supposed to be B, by the way, and then you can look at what customer B has purchased, because they share a lot of commonality between two customers. You can make recommendation product 3 to customer A. Yeah, and that's what you can do. And to wrap it up, if you want to learn more about the graph, and we have free resource called Graph Academy, and you can just go to the website and get certified. All the training, everything is free, and once you get certified, you get a free T-shirt, which I'm wearing right now. I got it last year. You'll probably have 2025 one, and you also have a deep learning course available for you. Thank you so much.
Round of applause. Thank you.